We are looking at problem 1012, where we're going to calculate not only the internal rate of return, but what we call the modified internal rate of return. And this is an investment by Buzz Lightyear, which is going to require this company to have an initial outlay of $10,000, and then they expect cash flows of $4,000 at the end of each year for the next 10 years. So once again, this is going to work like an annuity, not an annuity due, because the payments are at the end of the year. And when we get to our modified internal rate of return, we're going to need to assume a cost of capital or a discount rate of 10%. So let's go ahead and put that in first, 10%. And then let's put in our negative cash outlays, 10,000 there and 10,000 here. Negative, whoops, so that's got to be negative. So let me come up here and go negative, right? All right, whoops, that's not right. Let's try that again. Let's just try that again. Okay, come here and go negative 10, 0, 0, 0. Okay, there we go. Now we need to have cash flows of 4,000 for 10 years. So let's put in 4,000 and then just take that all the way down like so, and then copy that and then take that down like so, and there we go. Okay, now this is pretty straightforward right here. This is your internal rate of return, which is 38.45%, which seems pretty high when you consider the discount rate is 10%. Now, if you remember from your book, when they actually explain how we get the internal rate of return, we're assuming a reinvestment. As the cash flows accumulate, we're assuming a reinvestment at the internal rate of return at 38.45%, which is not always going to be realistic, which is why we end up with a higher internal rate of return than we may actually see. And I've actually got a little blurb here from the book. So to get around the internal rate of return reinvestment assumption, a variation of the IRR procedure has been developed called the modified internal rate of return method. The MIRR method calls for assuming that the intervening cash flows from a project are reinvested at a rate of return equal to the cost of capital. So we're going to reinvest over here at 10% versus 38.5% over here. The result is called the project's terminal value. Next, we calculate the annual rate of return it would take to produce that end amount from the beginning investment. That rate is the modified internal rate of return. So what you're seeing right here is you're seeing the same cash flows, and then in the purple I put in future value formulas. So as we get each added a future value, then I've done this separately for each one. So you can see that the future value of 4,000 that's invested in year one and earns 10% all the way through is going to be much higher than the future value of a payment. Remember, you get it at the end of the year, so that last payment you're not going to earn any interest at all on. So the future value is just 4,000. So which is also true of year 9. No, it's not. It's 4,400. Yeah, sorry. Okay, so that's what's going on here. Now, we can also come up with the same answer, and that's what gives us our terminal value, which acts exactly like, since all these cash flows are the same, this acts exactly like the future value of an annuity, which I've put in right here. So this formula right here is just the future value of an annuity formula. And once again, since these are all these cash flows are equal, this will work to give us the same answer as here. So we know that. Now, since we have Excel spreadsheet, I was able to go right up here and put in the actual formula for the modified internal rate of return. So if you look up here in the address bar, you can see it says equals MIRR parentheses, and then I put F16 through F26, which are the cash flows, including the negative cash outlay, and then comma, and G12 is just the assumed discount rate, and that's going to give us our modified internal rate of return. Well, what does that really mean? Well, it explains it here, but I also showed it here. So what it's saying is if we take the initial amount, which is 10,000, and we call that our present value, and we use this rate of return, our modified internal rate of return, which I put in here for a K, and then we compute the future value of that present value over 10 years, which is in here for N. So then we should get the exact same number as the terminal value here. So in other words, let's just show you that real quick. So the formula right down here is the future value of formula, where I've used I-26 for K is the where is it? I-26 is here, is the MIRR that we computed up here, okay, and the I-27 is the number of years, so to the power of 10, right? Get that out of the way. Move. He went. Oh, sorry. Sorry. Let me go back. Those things pop up. What up? Anyway, so, and let's see, where were we? And then let's see what else. And then the present value right here, I-25, is just the initial $10,000 cash investment. So what we're saying that if this discount rate right here, or this rate right here, the MIR, the modified internal rate of return, is the rate of return we would have to have in order to get to the terminal value here if we invested the initial 10,000 for 10 years, and once again at the rate of 20.35%. So you can also see that when we use this modified internal rate of return, when we assume that we're reinvesting at the discount rate, because if you look at all these formulas and we'll look at 1 plus G12, the rate I'm using right here is G12, which is 10%. So that's what I'm doing, and I did this manually so you can see. So we're reinvesting as our money grows, it's being reinvested at the 10% discount rate, as opposed to over here at the 38.5% internal rate of return rate. Okay, that is problem 1012. Oh, and make sure that you answer all three of these questions. I pretty much answered them for you, but you can, if you're not sure about a C, you can read here, and there's more about this in the book that will help you compose your answer to question C.